Chapter 1. Journey to the Red Planet. Envisage a universe where we, as humans, extend our existence beyond Earth, establishing Mars as our cosmic neighborhood. Quite an enticing concept, right? However, prior to planning our settlement on the Martian surface, we need to on the journey there. A voyage filled with unparalleled complexities and risks. Now let's paint a mental picture. A spacecraft, a titan of human innovation, technology, and engineering, embarking on a mission spanning millions of miles. This is not a journey for the weak-willed. The expedition to Mars alone could span 6 to 9 months. That's a considerable duration to be confined within a spacecraft, wouldn't you agree? Plus, the journey's duration isn't the only concern. The unforgiving void of space presents its own dangers. The crew would endure high radiation levels during the voyage. It's akin to receiving a full-body CT scan every 5 or 6 days. We're discussing radiation levels far beyond what we encounter on Earth, yet there's more. Solar flares pose an additional risk, potentially amplifying radiation exposure to perilous levels. Then there's the spacecraft to consider. It should be proficient in both completing the voyage and executing a safe landing on Mars. It's akin to engineering a vehicle that's capable of not only running a marathon, but also clinching a Formula One victory. A demanding task, but not an impossible one. We've successfully dispatched rovers to Mars in the past. We've managed to land a car-sized rover on Mars. And we've even witnessed a helicopter take flight on the Martian terrain, but transporting humans is an entirely different scenario. We're not merely discussing landing a spacecraft on Mars, we're addressing landing a spacecraft with humans aboard safely on Mars, and then ensuring their safe return. It's a colossal challenge demonstrating the power of human imagination and resilience. Tackling these obstacles is the initial stride towards transforming Mars into a second home. Chapter 2. Self-Sufficiency on Mars. Arriving on Mars is just the first hurdle. The subsequent challenge is surviving and thriving on this foreign planet. The question might arise, why is it essential to attain self-sufficiency on Mars? The explanation is straightforward. Depending on supply missions from Earth is not feasible due to the immense distance and prohibitive cost. We need to devise ways to live off the land. For survival, oxygen is vital. Thankfully, the Mars atmosphere predominantly comprises carbon dioxide, about 95%, offering the possibility of extracting oxygen using the right technology. One proposed solution lies in MOXIE, the Mars Oxygen In Situ Resource Utilization Experiment, a technology under trial by NASA. This device, about the size of a car battery, has the potential to convert carbon dioxide into oxygen, thus offering a sustainable source of breathable air. Another crucial survival resource is water. While Mars' nickname, the Red Planet, might suggest otherwise, this planet is far from devoid of water. Scientists have found signs of water ice below the Martian surface, particularly in the polar regions. Future missions might be able to extract this water for varied uses like drinking, growing food, and even producing rocket fuel. When talking about self-sufficiency, we cannot overlook the importance of food. Mars's harsh climate and infertile soil make traditional farming impractical. However, innovative solutions like hydroponics and aeroponics, which allow for soil-less plant growth, are under consideration. These methods could provide a continuous source of fresh food for Martian denizens. It's crucial to remember that attaining self-sufficiency on Mars is not going to be a walk in the park. It needs a blend of cutting-edge technology, inventive problem-solving, and relentless effort. Yet, with the right tools and tenacity, it's achievable. With the right application of technology and resources, we can transform Mars into a self-sustaining colony. Chapter 3. Governance on Mars. How do we impose order and unity in an unfamiliar world? This question becomes prominent as we ponder the creation of AA on the Red Planet. As we step into the unknown, the administration of a Martian colony poses a peculiar test. In the beginning, a hierarchical command system, guided by the mission leaders or the space agencies funding the journey, seems a likely approach. This structure is recognizable, echoing the systems on naval ships or Arctic research bases on our home planet. However, as we transform from an expedition to a colony, from a team to a society, this system might not suffice. The hierarchy that works effectively in a compact, specialized squad may not smoothly transition to an expansive, varied populace. As the Martian colony expands and flourishes, a move towards a democratic form of rule might be more fitting. Implementing democratic processes would cater to a wide range of interests, averting power monopoly and potential tyranny. But this brings forth another set of queries. What would Martian democracy encompass? Will it reflect the systems we familiar with on Earth? Or will it be an entirely novel concept, molded by the distinct complications and prospects of Martian life? How do we ensure fairness, equality, and representation of all settlers in this system? These are the conundrums we need to confront as we prepare life on Mars. Establishing a government isn't just about preserving order, but about constructing a system that embodies the principles of the society it governs. It's about laying the groundwork for a society that is not merely surviving, but prospering. As we envision the future, we must acknowledge is not only a target, it's our new abode. And like any household, it necessitates a fair, efficient system of rule. A system that encourages collaboration, stimulates development, and safeguards the well-being of all its residents. Therefore, as we embark on the journey to colonize Mars, we must also lay the groundwork for a governance system that is up to the challenge. Building a fair and effective government is essential for the successful establishment of a Martian colony. This is the challenge and the opportunity as we anticipate the commencement of a new epoch of space exploration. Chapter 4: The Cost of Colonization. The endeavor to colonize Mars is not just a technical challenge, but also a formidable financial one. When the topic of space travel comes up, we often visualize rockets, hardy astronauts, and the boundless cosmos. However, we seldom spare a thought for the colossal expenditure that is associated with these ventures. Let's break down the numbers for a clearer picture. The Apollo program, credited with landing the first man on the moon, had a budget of around $25 billion, and this was in the currency of the 1960s. Now let's consider that Mars is over 200 times further away than the moon, making the financial hurdles even more daunting. The cost of colonizing Mars goes far beyond just reaching the planet. The building of a spacecraft sturdy enough to withstand the lengthy journey, safely land on Martian terrain, and potentially return to Earth is a considerable investment. This is not a one-way ticket, it's a round trip. Furthermore, the spacecraft must be equipped to sustain life for the duration of the journey, which could span anywhere from 6 to 9 months. The costs, however, just begin with landing. Setting up a sustainable habitat on Mars comes with its own set of expenses. This includes not just the physical structures, but also the systems needed to separate oxygen from Mars's atmosphere, find and extract water, and produce food. All this technology and infrastructure come with a hefty bill. And we mustn't forget about the expenditure on human resources. The people who will make this colonization possible. The astronauts, the scientists, the engineers, they all need to be trained, compensated, and supported. This is a long-term investment in human capital that cannot be overlooked. In conclusion, the financial implications of colonizing Mars are enormous and complex. It demands meticulous planning and management to ensure the mission's financial viability. We must carefully evaluate the costs and benefits and make strategic decisions about where and how to allocate our resources. While the cost is substantial, the potential payoff, a second home for humanity, could indeed be priceless. Chapter 5: The Future of Mars Colonization. The prospects of making Mars our second home are no longer confined to the realm of science fiction. In fact, it is a rapidly approaching reality, as esteemed bodies such as NASA, Mars One, and the Mars Society are diligently striving to attain this epic objective. The strides taken so far are truly remarkable, steadily steering us towards revolutionizing the red planet into an outpost for mankind. Envision a flourishing human society on Mars, symbolizing our inventiveness and aspiration. Advantages and prospects it offers are limitless, ranging from revolutionary scientific discoveries to the unprecedented opportunities for interplanetary commerce and even tourism. As our quest for discovery continues to break new boundaries, Mars emerges as the next frontier,